This is Mrs. O'Neill for AP Chemistry, Chapter 24, Section 1. And as you can see, we're only doing the first 4 sections in this chapter. And this chapter is the chemistry of life, organic and biological chemistry. Why Chapter 24 first, all the way at the end of the textbook instead of Chapter 1? Well, throughout the course, you will see organic substances, so I really want you to be familiar with them. Also, it seems that every year on the AP Chem exam, 1 or 2 or a few questions in the multiple choice and or free response uses organic structures, organic molecules to answer questions. There won't be detailed questions about organic material or the curriculum about organic, but there will be questions on intermolecular forces, and they will use organic substances to have you answer those questions. So as always, define terms on page 1043. It is up to you how you want to do that, but make sure that you're familiar with those terminology. I always like to start the chapter with the information paragraph that they give us. So on 1004, insects communicate by releasing substances called pheromones, which they detect with their antenna. There are sex, alarm, defense, and trail pheromones. For example, isoamyl acetate, or also called 3-methyl-butyl acetate. And here is the structure, and this is what makes organic chemistry a little bit difficult. As you can see, there are 2 different ways to name this particular substance, and this is one way that the structure is drawn out. If you watch the video, which you should have already, it also talks about the 4 different ways of drawing, or you'll be able to see the differences in the structures that organic compounds are given to you. Anyways, this particular substance is an alarm pheromone for bees, attracting other bees and provoking them to sting. Mammals, including humans, may also respond to pheromones, although the identity and function of pheromones in humans are not conclusive. So the first thing you should have done is watch the video and take some notes on representing structures of organic molecules. These were my notes that I took. First thing they talked about is how carbon is really the backbone, if you will, for organic compounds. So any organic compounds always have carbon in them. And what's so special about carbon? Well, he has 4 valence electrons because he is in group 14 on your periodic table. But just like every other element, he wants 8 valence electrons to be happy. Well, hydrogen's the perfect partner for this. Hydrogen has 1 valence electron. It only needs 2, so it's going to bond here. Another hydrogen is going to use this electron. Another hydrogen is going to bond here, and this one's going to be attracted to this electron. So what happens is you may use dots or lines to represent this compound called methane. So you can use dots, you can use lines, and they both represent this compound meth and then ane. And that's going to be real important to remember these prefixes and endings for these compounds. So he talked about how, again, 2 dots or 1 line can represent a single bond. So we talked about the 4 different structures. One is the Lewis structure. Should be familiar with that one, called the Lewis dot diagram, same kind of thing. The structural formula, we're just going to change 2 dots to equal 1 line. He also talked about the condensed formula, and the condensed formula, just like we saw in that beginning paragraph, is a nice way of writing things, but then it doesn't give you that visual. So you have to visualize yourself that this carbon is going to have 1, 2, 3 hydrogens attached to it. The second carbon is going to have 2 hydrogens attached to it, basically up and down. And the third carbon is going to have, again, 1, 2, 3 hydrogens attached to it. So now you have to familiarize yourself with how that's going to look. And then the line diagram, or the skeletal formula, again, it's nice and condensed, but now you have to make sure you're understanding that each one of these angles, let's say, or each one of these lines would represent a carbon here, a carbon here, a carbon here. And because there's no other element, you're just going to have to understand, or it's understood, that there would be 3 hydrogens here, 2 hydrogens here, and 3 hydrogens here. So there you go, all together, propane. So again, I want you to understand that the prefix pro is going to mean 3 carbons, and the ending ane is going to mean that these are all single bonds attached to each other. So those are things that we're going to talk about in the future. So again, why it's really important is that you'll see these types of structures throughout the textbook, and we want to make sure that you're familiar with that. So on to section 1, general characteristics of organic molecules. I will remind you, you might want to pause the video, fill in the blanks in your packet, and then play to hear my words. So the objective is going to be knowing the structures and reactivities of these organic compounds. So again, to your packet. Organic chemistry, studying compounds that contain carbon. The structure of these organic molecules. Again, the idea that carbon has 4 valence electrons, so it wants to bond 4 times in some way. The CC bond that we saw in the video as well is called the skeleton part of the molecule, and the CH is always going to be the surface or around the carbon, because remember, hydrogen only needs 2 valence electrons in order for it to be happy or in order for it to be stable, so it has to be on the outside of the molecule. Carbon will form strong bonds definitely with hydrogen, as well as oxygen, nitrogen, and halogens, which is group 17 on your periodic table. Carbon is real strong where it bonds with itself in long chains as well as in rings. There's going to be functional groups, and these functional groups are going to determine how reactive a molecule is. So solubility and acid-base properties. Solubility of organic substances are usually low, okay, because most of them are non-polar. So if you have something that's non-polar, it's only going to dissolve or be soluble, right? Those two mean the same thing, soluble or dissolve, in non-polar solvents. So oil is a very, very organic substance, so it does not dissolve in water because oil is non-polar and water is polar, so they do not dissolve nicely with each other. They also contain what's called a functional group for acids and base. So an acidic organic compound, we're going to call them carboxylic acid, and they're going to have an attachment COOH. So your carbon is going to be attached to an oxygen, another oxygen, and a hydrogen, and we'll talk more about that, I believe, in a later section. And for base, you're not going to see this too often, but most of your bases contain what's called an amine group or an amine functional group that has nitrogen with these R's, hydrogen or R's, and these R's are just more carbon-hydrogen atom groups. That's it. I'm hoping that you have questions for me when you come back to class.